In just 18 days, something ancient will sweep past Earth, an object older than our solar system, a visitor from another star, and on December 19th, 2025, it will make its closest approach to our planet. This is 3I Atlas, the third confirmed interstellar object in history. Right now, it's racing through our solar system at over 150,000 miles per hour, and scientists around the world are scrambling to study it before it vanishes forever. But here's what makes this moment so critical. This comet has been doing things that shouldn't be possible. It's been ejecting billions of tons of material while somehow staying intact. It's showing jets pointing in directions that defy physics. And the newest data from just yesterday reveals it may be accelerating in ways we can't explain. NASA has mobilized an entire fleet of spacecraft to study this object. From Mars orbit to Earth orbit to deep space probes, this is the most coordinated observation campaign of an interstellar visitor in human history. I'm going to break down exactly what's happening with 3I Atlas, what we'll see on December 19th, and why this might be our only chance to study an object like this in our lifetimes. Let's start with how we found this thing. July 1st, 2025, a robotic telescope in Chile called ATLAS, the Asteroid Terrestrial Impact Last Alert System, was doing what it does every clear night, scanning the sky for dangerous asteroids. ATLAS wasn't looking for interstellar visitors. Its job is planetary defense. Find the rocks that might hit Earth and give us enough warning to do something about it. But on that July night, it detected something moving through the constellation Sagittarius. The system automatically flagged it and sent the data to the Minor Planet Center. And when astronomers calculated the preliminary orbit, they got concerned. The initial trajectory suggested this object might pass dangerously close to Earth. Within hours, professional and amateur astronomers around the world started digging through archival images. They found pre-discovery detections going back nearly 4 weeks. The object had been there all along, just too faint to trigger automated alerts. But when bigger telescopes pointed at this object on July 2nd, they saw something unexpected. Instead of a sharp point of light like an asteroid, there was a fuzzy glow around it, a coma. That meant this wasn't a rock, it was a comet actively releasing gas and dust. So it got designated C2025N1, Atlas. The C stands for comet, and as more observations came in over the following days, astronomers refined the orbit calculation. The good news? The initial prediction about a close Earth approach was completely wrong. This comet wasn't going to come anywhere near us. The closest it would get is 170 million miles, nearly twice the distance to the Sun. But what they discovered instead changed everything. The orbit wasn't elliptical like normal comets. It was hyperbolic, and that meant one thing. This object came from another star system. That's when it received its current name, 3I Atlas. The 3I stands for Third Interstellar Object, because this is only the third time in human history we've confirmed something passing through from beyond our solar system. You probably remember 1I Oumuamua, that cigar-shaped mystery from 2017, and 2I Borisov in 2019, which looked like a normal comet. But 3I Atlas is different from both of them in almost every way. Here's what makes 3I Atlas so remarkable. This object is old, really old, possibly 7 to 14 billion years old. To put that in perspective, Earth is 4.6 billion years old. Our entire solar system is 4.6 billion years old. 3I Atlas might be 3 times older than that. It could have formed before our Sun even existed. Astronomers have traced its origin to a region of the Milky Way called the Thick Disk. This is a population of old stars orbiting high above and below the main galactic plane. It's a quiet neighborhood, fewer collisions, fewer supernovas, fewer catastrophic events. Researchers have actually backtracked 3I Atlas's journey over the past 10 million years. During that time, it encountered 93 different stars. But here's what's fascinating. The closest it ever came to any of those stars was 0.3 light-years away. That's 63,000 astronomical units. For comparison, right now 3I Atlas is only 1.4 AU from our Sun. So for 10 million years, this comet has been drifting through the lonely void between stars. And we're the first solar system it's actually visited. It came from the direction of Sagittarius, near the galactic center, and it approached our solar system from an unusual angle, almost perfectly aligned with the plane of our planets. Our solar system is basically a flat disk. All the planets orbit in roughly the same plane, called the ecliptic. 3i Atlas came in at only 3 degrees off from this plane. In a three-dimensional universe where it could have approached from literally any direction, it hit us almost perfectly edge-on, and it's moving fast. When it was discovered out near Jupiter's orbit, it was traveling at about 137,000 miles per hour. As it fell toward the Sun, it accelerated to roughly 153,000 miles per hour, near its closest approach in late October. That speed is way above the Sun's escape velocity at that distance, which confirms what the orbit already told us. This object is not gravitationally bound to our Sun, it's just passing through. One of the first questions astronomers wanted to answer was simple: how big is this thing? Early reports suggested it could be anywhere from 7 to 15 miles wide. That would make it enormous, bigger than most comets we've ever studied, but those estimates were based on limited data. So NASA pointed the Hubble Space Telescope at 3i Atlas. Hubble has been observing comets for decades, and it's really good at measuring their size. But there's a problem. When you look at an active comet, you can't actually see the solid nucleus directly. It's shrouded in a bright cloud of gas and dust, the coma. So Hubble can't just take a picture and measure the nucleus like you would with an asteroid. Instead, astronomers have to infer the size from how much light is scattered by dust and gas close to the surface. They look at the brightness, the color, and how the light changes over time. Then they work backwards to estimate the size of the solid core. After careful analysis, Hubble gave us a range. The nucleus of 3i Atlas is somewhere between 1,400 feet and 3.5 miles across. The lower end, 1,400 feet, is about the height of the Empire State Building. The upper end, 3.5 miles, is roughly the length of Manhattan from the Battery to Central Park. That makes 3i Atlas significantly larger than Oumuamua, which was maybe 1,300 feet long. And it's bigger than 2i Borisov, which was about 3,000 feet across. If 3i Atlas is at the upper end of that size range, it's the largest interstellar object we've ever observed. If we assume it's roughly spherical and has a density similar to other comets, about half the density of water ice, then a 1 kilometer wide nucleus would weigh somewhere around 500 million tons. If it's closer to 5 kilometers wide, we're talking about tens of billions of tons. Now let's talk about what this thing is made of, because that's where things get really weird. In August, the James Webb Space Telescope analyzed the composition of 3i Atlas's coma. JWST can detect specific molecules by looking at the wavelengths of light they absorb and emit. What they found was carbon dioxide, water vapor, and carbon monoxide. All of these are common in comets, but the ratio was completely wrong. 3i Atlas has about 8 times more carbon dioxide than water. That's basically the inverse of what we see in comets from our solar system, which are dominated by water ice. If you've ever seen dry ice, frozen CO2, you know it doesn't need much heat to start sublimating. The moment you take it out of the freezer, it immediately starts creating that smoky fog. It's extremely volatile. That's why 3i Atlas started forming its coma way out beyond Jupiter's orbit, over 5 AU from the Sun. Normal comets don't start out gassing until they get to about 3 or 4 AU, because water ice needs more heat to sublimate. But here's where it gets stranger. As 3i Atlas continued its approach toward the Sun, the composition started to change. By late September, as it passed through Mars's orbit, it suddenly started releasing massive amounts of water vapor. The ratio of CO2 to water started to flip. The comet was becoming more normal over time, but through a process we've never seen before. And then there's the metal. When astronomers analyzed the coma during the summer, they detected nickel. Lots of nickel. But they didn't detect any iron. That's bizarre because nickel and iron almost always appear together in space. Both elements are forged in the cores of dying stars. When those stars go supernova, they blast these metals out into space. Because they come from the same source, they're usually found together in roughly the same proportions. So when we see lots of nickel but no iron, we have to ask, where did the iron go? What process separated them? Then, by late September, astronomers suddenly started detecting iron in the coma for the first time. And very quickly, the ratio of nickel to iron shifted to a more normal combination. Once again, 3I Atlas was becoming more normal over time, but through a bizarre process that doesn't match any comet model we have, because 3I Atlas spends much of its journey on the far side of the Sun, as seen from Earth. NASA and ESA turned this into a coordinated observation campaign stretching across the entire solar system. This is unprecedented. We've never had this many spacecraft in position to study an interstellar object from multiple angles simultaneously. Let's start at Mars. On October 2nd, NASA's Mars Reconnaissance Orbiter captured one of the closest images of 3I Atlas from about 19 million miles away. The high-rise camera on this orbiter is one of the most powerful telescopes we have in space. The MAVEN orbiter, which studies Mars's atmosphere, recorded ultraviolet emissions from hydrogen gas around the comet. This revealed how solar radiation strips water molecules apart, creating a glowing hydrogen cloud. Even the Perseverance rover on the surface of Mars managed to capture a faint glimpse of the comet in the night sky. It's not a great image. The rover's cameras weren't designed for astronomy, but it's still remarkable. The European Space Agency's ExoMars Trace Gas Orbiter also observed 3I Atlas from Mars orbit, and here's where it gets interesting. By combining ExoMars data with Earth-based observations, ESA was able to improve predictions of 3I Atlas's position by a factor of 10. This is called triangulation. When you observe the same object from two widely separated locations, you can pinpoint its position and velocity much more accurately. This technique is crucial for planetary defense. If we ever need to deflect an asteroid, we need to know exactly where it is and where it's going. NASA's SOHO and STEREO missions tracked 3I Atlas as it passed behind the Sun, capturing its faint coma and tail where ground-based telescopes couldn't see it. These spacecraft are designed to study the Sun, but they're also excellent at detecting comets in the Sun's glare. The new PUNCH mission, polarimeter to unify the corona and heliosphere, also captured images of 3I Atlas during this critical phase. PUNCH was launched specifically to study how the solar wind interacts with objects in space. Even NASA's Psyche and Lucy spacecraft, which are on their way to study asteroids, took long-distance images of 3I Atlas. These observations help refine the comet's orbit and reveal the structure of its dust coma and tail. And of course, Hubble has been observing 3I Atlas multiple times throughout its journey, providing the highest resolution images of the nucleus and coma. This coordinated many eyes on one comet approach is giving scientists an exceptionally detailed, three-dimensional view of an interstellar object in real time. We've never had this kind of coverage before. Now let's talk about the biggest mystery of all. According to the math, 3I Atlas should have broken apart by now, but it hasn't. On November 9th, astronomers captured images showing 3I Atlas with massive tails extending millions of kilometers into space. One tail pointing toward the Sun stretched about 620,000 miles. The other, pointing away from the Sun, stretched nearly 1.9 million miles. For comets, gas flows out at only about 1,500 kilometers per hour. That's pretty slow for space. For tails to stretch millions of kilometers at that speed, the comet would need to be shooting out gas constantly for a couple of months. But images from just a few days earlier showed absolutely no tail at all. So these massive structures appeared suddenly, which doesn't fit the natural sublimation model. Here's the second problem. To produce tails of this size and brightness, the comet would need about 1,600 square kilometers of surface area absorbing sunlight. That's equivalent to a sphere 23 kilometers across, but Hubble measured 3I Atlas at only 5.6 kilometers in diameter. The math says it needs to be 4 times bigger than it actually is, and it gets worse. Calculations show 3I Atlas has to be losing about 50 billion tons of material per month. That's disturbing when you consider the entire object is estimated to weigh only about 33 billion tons. It's losing more mass than it weighs. That's physically impossible for a solid object. We've seen this before. In 1994, comet Shoemaker-Levy 9 broke apart under Jupiter's immense gravity, forming a string of fragments before plunging into the planet's atmosphere. When astronomers calculated the total mass released, it was way more than the original comet should have weighed. But that made sense once we realized it had fragmented into 21 different pieces. More surface area means more sublimation, which means more visible jets and tails. So the only logical explanation for the 7 jets seen on November 8th and the massive tails in the November 9th images was that 3I Atlas had fragmented into multiple pieces. But then came the November 11th observations. Two astronomers, David Dewitt and Jane Liu, pointed a telescope in the Canary Islands at 3I Atlas. They observed a region around the comet that was about 500,000 kilometers wide, specifically looking for any signs of breakup. When they published their findings, they gave it a very simple title: 3I Atlas Still Single. What they found was one single bright nucleus. No fragments, no debris field, no spreading pieces, just one solid object, actively producing enormous jets in multiple directions. They used multiple image processing techniques, stretched brightness, contour maps, false colors, radial profiles. Every technique was designed to find even small pieces if they were there, and they found nothing. Remember, this was 2 weeks after perihelion, the closest approach to the Sun on October 29th. The object had just been through the most intense heating of its entire journey. The thermal stress should have cracked it apart. The pressure from all that gas shooting out should have blown it into pieces, but it's still intact, still one solid object, somehow. On December 1st, a new study added another layer to this mystery. Researchers using the Joan Oro telescope in Spain reported evidence that 3I Atlas may be erupting in ice volcanoes or cryovolcanoes. Now, before you get too excited, this hasn't been peer-reviewed yet. But the observations are intriguing. The researchers found spiral jets of gas and dust rising from the comet, which they interpret as cryovolcanic plumes. These would be triggered as sunlight heats buried volatile ices, causing sudden eruptions rather than steady sublimation. They also found spectral fingerprints suggesting similarities to trans-Neptunian objects in our own solar system, distant, icy worlds beyond Neptune like Pluto and Eris. This implies that although 3I Atlas formed around another star, its building blocks may resemble the outermost material of our own system, which makes sense. The cold outer regions of planetary systems should be similar across the galaxy. If this cryovolcano interpretation is correct, it would mean 3I Atlas is geologically active, not just passively sublimating like a normal comet, but actively erupting. That could explain some of the anomalies we've been seeing. But again, this is preliminary. We need more observations and peer review before we can say for sure. There's another strange pattern that's been detected: a regular pulse in the comet's brightness. A paper published in Astronomy and Astrophysics described a 16.16-hour periodic modulation in the light from 3I Atlas. The brightness goes up and down in a regular cycle, like a heartbeat. The most likely explanation is rotation. As the comet spins, different parts of its surface face the Sun. If there are active jets on one side and not the other, we'd see brightness variations as those jets rotate in and out of view. The 16-hour period would be the rotation period of the nucleus, and the brightness changes would be caused by jets switching on and off as different parts of the surface heat up and cool down. Some researchers, including Harvard astrophysicist Avi Loeb, have speculated more boldly. Could this regular pattern hint at artificial activity? Could it be a signal? During a widely covered NASA briefing, officials addressed this directly. They reiterated that no techno-signatures or artificial signals have been detected. Everything observed so far is fully consistent with a natural comet. The authors of the original study describe 3I Atlas as behaving like a weakly active outer solar system comet. The rotational explanation fits the data naturally. There's no need to invoke anything exotic. So yes, the heartbeat is real, but the simplest explanation is that we're watching a spinning, jetting comet, not an alien spacecraft. So let's talk about December 19th. What's actually going to happen? On December 19th, 2025, at approximately 0600 UTC, 3I Atlas will reach its closest point to Earth. The distance will be 1.8 astronomical units, about 170 million miles or 270 million kilometers. To put that in perspective, that's nearly twice as far away as the Sun. It's more than 700 times the distance to the Moon. So despite the dramatic headlines, this is not a close approach by any reasonable standard. NASA has been very clear. 3I Atlas poses no danger whatsoever. It won't come close to Earth at all by planetary defense standards. There is zero risk of collision. But December 19th is important for a different reason. It's our best viewing window. From now through mid-December, 3I Atlas is in the most favorable position for observation from Earth. According to NASA's What's Up December 2025 guide, the best time to observe is in the early pre-dawn hours. Look east to northeast. The comet will sit just below Regulus, the bright star marking the heart of Leo, the lion. Right now, 3I Atlas is around magnitude 10. That's far below naked eye visibility. You won't see this with binoculars. You need a telescope. NASA recommends a telescope with at least a 30 centimeter, 12-inch aperture to see the comet as more than a faint smudge. Experienced astrophotographers with instruments in the 30 to 40 centimeter class are capturing detailed views. If you don't own a large telescope, check with local observatories, universities, and astronomy clubs. Many are planning public viewing nights around December 19th. The Virtual Telescope Project will host a live online broadcast of 3I Atlas at minimum distance, starting at 4:00 UTC on December 19th. There'll be streaming views from professional-grade telescopes in Italy. So even if you can't observe it yourself, you can watch it live online. You can also follow the comet's path in real time using NASA's Eyes on the Solar System interactive simulation, which includes a dedicated 3I Atlas mode. While amateur astronomers are trying to catch a glimpse, professional observatories around the world will be conducting intensive observations. They'll be measuring the comet's brightness, analyzing its composition, tracking its jets, and looking for any signs of change from its close pass by the Sun. Spectroscopy will reveal what molecules are being released. Photometry will track brightness variations and rotation. High-resolution imaging will search for fragments or structural changes. All of this data will be compiled over the coming weeks and months, and it will help answer the fundamental questions. How is this object staying intact? What's causing the anomalous mass loss? And what can it teach us about planetary systems beyond our own? So what happens after December 19th? After its closest approach to Earth, 3I Atlas will continue outward. It will pass within about 0.36 AU of Jupiter in March 2026 before leaving the solar system altogether. NASA's Juno probe, which has been studying Jupiter for nearly a decade, may have a chance to capture one last image of the comet as it passes by. As 3I Atlas moves farther from the Sun, it will gradually fade. The sunlight weakens, the heating decreases, and activity subsides. Ground-based observers should be able to follow it with telescopes into spring 2026, but it will become increasingly difficult to see. And then it's gone, back into the void, never to return. But for scientists, the real work will only be beginning. Years of modeling, lab experiments, and data analysis aimed at decoding what this ancient shard of another planetary system is trying to tell us. So why does any of this matter? Why should we care about a comet that's not going to hit us and that we can barely see? Because 3I Atlas is only the third confirmed interstellar object in human history. We've been looking at the sky for thousands of years, and we've only caught 3 of these visitors. Each one is a window into another star system, a sample of material that formed around a different sun, in a different environment, under different conditions. We can't travel to other star systems yet, but occasionally they send us samples. If 3I Atlas truly is 7 to 14 billion years old, it's a fossil from deep galactic history. It preserves chemistry from an era long before the Sun and planets even existed. It's older than Earth. older than the solar system, possibly older than most of the stars we can see in the night sky. Studying this object lets scientists test models of planet formation in environments that existed billions of years before our own system formed. It challenges our assumptions about what's normal in the universe. The unusual CO2-rich composition and hints of cryovolcanism challenge existing theories of comet chemistry. They hint at diverse planetary architectures across the galaxy. Not every solar system is like ours. For agencies like NASA and ESA, 3I Atlas is also an ideal test case for planetary defense. It's a fast-moving, faint object whose orbit must be nailed down quickly. The success of techniques like Mars-based triangulation will feed directly into how we respond to any future object that does come close. Traveling at over 130,000 miles per hour, it's one of the fastest comets ever observed. Its speed and trajectory encode the gravitational tugs it has experienced from stars and nebulae over cosmic time. And perhaps most importantly, 3I Atlas reminds us that science is about embracing mysteries. When something doesn't fit our models, we don't ignore it. We study it harder. We ask better questions. We build better theories. As we approach December 19th, there are still so many unanswered questions. How is 3I Atlas staying intact while losing more mass than it weighs? Is the cryovolcano interpretation correct? What's causing the 16-hour brightness variation? Why did the composition change so dramatically as it approached the sun? Where did all the iron go, and why did it suddenly reappear? Is the surface covered in a weird crust created by billions of years of cosmic ray bombardment? Does that crust create channels and pockets that give the comet more effective surface area than we can see? Is 3I Atlas a solid chunk of ice and rock, or is it more like a rubble pile, loosely bound fragments held together by weak gravity? Could that explain the anomalous outgassing? Or are we simply calculating the mass loss incorrectly? Maybe the tails are better at scattering sunlight than we think. Maybe they look bigger than they actually are in terms of mass. The observations being conducted right now, through December 19th and beyond, will help answer some of these questions. But they'll also raise new ones. That's how science works. And here's something to think about. We've now detected 3 interstellar objects in just 8 years. Oumuamua in 2017, Borisov in 2019, 3I Atlas in 2025. As our telescopes get better and our survey systems improve, we're going to find more of these visitors. Maybe one per year, maybe more. Each one will teach us something new about the galaxy we live in. The Vera Rubin Observatory, which will begin operations soon, is expected to detect dozens of interstellar objects per year. We're entering a new era of interstellar astronomy. And 3I Atlas is a pioneer, the most intensely studied interstellar visitor so far, the one that's teaching us how to do this right. So here we are, December 1st, 2025, just 18 days until 3I Atlas makes its closest approach to Earth. For the next 2.5 weeks, this ancient visitor from another star will be at its brightest and most observable. Telescopes around the world are pointed at it. Spacecraft across the solar system are tracking it. Scientists are analyzing every photon of light it reflects. This comet has broken every rule. It's older than our solar system. It's made of the wrong stuff. It's losing more mass than it weighs. It's staying intact when it should have shattered. It's showing jets in impossible directions. And it's teaching us that the universe is far stranger and more diverse than we ever imagined. On December 19th, if you have access to a large telescope or can join a public viewing event, take the opportunity to see this object with your own eyes. It's a once-in-a-lifetime chance. And if you can't observe it yourself, tune in to the Virtual Telescope Project's live stream at 0400 UTC. Watch as professional astronomers capture this moment in real time, because soon 3I Atlas will leave. It will return to the vast emptiness between stars, continuing a journey that began billions of years ago and will continue for billions more. We'll never see it again, but the knowledge it leaves behind will shape our understanding of the universe for generations to come. It's a message in a bottle from another sun, a cosmic postcard from deep time. And on December 19th, 2025, it will be at its closest. Don't miss it. If you want to learn more about the other interstellar visitors that have passed through our solar system, check out this video where I break down the mystery of Oumuamua and the debate over whether it could be artificial. Thanks for watching, and I'll see you on December 19th.